So here is the last scenario, which is given 3 points on the plane. So the equation of a plane determines by 3 points A, B, C on the plane can be obtained by, so first we can find the vector of AB and AC. Why we have to find the vector of AB and AC? Because in order to find the normal vector again, we need two different vectors. So from these 3 points, we can find AB and AC. So then we use the normal vector. Well, we find the normal vector by using the cross product. And then we have the normal vector. Next is the P naught. So against the P naught, you have 3 points to choose from, which is A, B, and C. You can choose either one, A, B, or C as our P naught, since there are 3 points on the plane. So any of these points can be our P naught. So what we have to do is we have to find two vectors first, two different vectors, and then find the normal vector by using cross product. And then the P naught, we have 3 points, either A, B, or C as our P naught. And then finally use the normal vector. So you can see from find the equation of the plane, this example 4 passes through the point A, B, and C. So you can see in this case we have 3 points on the plane. So we can form the vector AB and AC. What is the formula? Negative A plus B or negative A plus C. And another one is negative A plus C. From this, we can get the two vector, vector AB, vector AC. So then what we do? We do the cross product as our normal vector. So the cross product, we will get the normal vector. So X naught, P naught, and Z naught, this is our P naught. Here is our P naught. You can use X naught, Z naught, Y naught, X naught, Y naught, Z naught. So in this case, using the A as the point. So which is 1, negative 6, and 0. Here, 1, negative 6, and 0 is our P naught. So by using this formula, the dot product of normal vector, which is 58, 20, and negative 26, dot product with x minus 1, this is 1, y minus negative 6, this is actually is y minus negative 6. So that's why this here is y plus 6. And then z minus 0 is equals to 0. And then from here, we can get the normal vector. Actually, this one you can simplify by dividing 2. So, again, determine the vector and the equation of the plane contain the point P, Q, and R. So, what we do, what is our first step? If you still remember, we will find the vector of PQ and vector of PR. So, this is our first step. Find the vector of PQ and PR. So, how are we going to find the PQ and PR? If you still remember, the formula is negative P plus Q. So, negative, our P is 1, negative 2, and 0. 1, negative 2, and 0. Plus Q. Q is 3, 1, and 4. 3, 1, and 4. So, from here, we should have negative 1, positive 2, and 0. Plus 3, 1, and 4. So how I can get this one? I just move negative inside the bracket. Negative 1, negative, negative will become positive 2. Negative 0 is 0. So here, negative 1 plus 3 is positive 2. 2 plus 1, 3. 0 plus 4, 4. So this is our first vector. Second vector, we can use PR. So for PR is negative P plus R. So here is negative 1, negative 2, and 0 plus R. Our R is 0, negative 1, and 2. So here we should have negative 1, positive 2, and 0 plus 0, negative 1, and positive 2. So here negative 1 plus 0 is negative 1. 2 plus negative 1 is positive 1. 0 plus 2 is 2. So we have two vector. We can find the normal vector by using the cross product I, J, and K, which is 2, 3, 4, negative 1, 1, and 2. So using the cross product, the first one is positive. Like I just mentioned before, close the first row and the first column. 3, 4, 1, and 2. 3, 4, 1, and 2. The second is negative J. Don't forget. First column, first row, second column. 2, 4, negative 1 and 2. 2, 4, negative 1 and 2. And finally plus k. First row, third column. 2, 3, negative 1 and 1. 2, 3, negative 1 and 1. So from here, 3 times 2, 6, minus 4 times 1, 4, minus j, 2 times 2 is 4, minus 4 times negative 1 is negative 4. Don't forget to change it to square bracket, plus k. Here is another square bracket. 2 times 1 is 2, minus 3 times negative 1 is negative 3. So from here, 6 minus 4 is 2i. 4 minus negative 4 is plus 4 is 8, negative 8j. And finally, here is plus 2 minus negative 3 is 5k. I can change into the coordinate form, which is 2, negative 8, and 5. So here is our normal vector. And our P note, there are 3 points to choose from. You can choose either which point, P, Q, or R. 1, negative 2, and 0. Let's say 1, negative 2, and 0. Or you can choose another point, Q, 3, 1, and 4. 3, 1, and 4. Or you can choose the last point, which is R, 0, negative 1, and 2. 0, negative 1, and 2. So in this case, I choose this point. It's up to you. You can choose the second or third point. So based on the formula, the equation of the, let's say, I mentioned here, equation of the plane. And the formula is the dot product of the normal vector with P minus P naught is equals to 0. So our normal vector is this one, which is 2, negative 8, and 5. Dot product P is x, y, z. So x minus the first value is 1, comma, y minus the second value is negative 2, put a bracket negative 2, and then z minus the third variables is 0, is equals to 0. So here 2 times x minus 1, the dot product, minus 8 times y plus 2, and then plus 5 times z is equals to 0. So here we have 2x minus 2 minus 8y minus 16 plus 5z is equals to 0. Rearrange this one. 2x minus 8y plus 5z. Negative 2 minus 16 is negative 18 is equals to 0. So here is our equation of the plane. So in the final scenario, you can see that we have 3 points is given. So 3 points is given. First, we have to find two vectors from these 3 points. I use the PQ and PR. So here is the formula, negative P plus Q, negative P plus R. From here, we will get two vectors. Then, in order to find the normal vector, we are using the cross product. So here is our normal vector, which is our N. And then, for the P node, you can use either, we have 3 points here. Both the three points also on the plane. 3 of the point, all of them are on the plane. So you can use the first point P, Q, or R. It's up to you. In this example, I'm using the P, the point P, which is 1, negative 2, and 0 as our P node. So substitute into the formula of the equation of the plane. This is the normal vector. Dot product with x minus. This is the point from the point P. P node. This is our P node, which is the point P. So from here, you try to expand and you should get the equation of the plane.